Welcome everybody to a fourth class of TDD. We are C++ Londonini, and I'll try to get into habits and do this properly. So first, let's introduce ourselves. My name is Tom Breza. I'm one of the hosts. Oliver Dean is another. He's leading today's class. We have Tristan, who is another one of our teachers. And today as well, one of the rare guests is Justin. Uh, so, first of all, thank you to Mimecast for giving us the space and refreshments and some food. Thank you very much. Really appreciate it. Without you, we wouldn't have a class. So, a massive thank you. But as well, a massive thank you to our patrons. Patrons are people like you who decide to sponsor us and pay on a regular basis some money to us. They assume our project is good enough, and because of that we can improve even on a technical side, buy equipment and so on. So whatever you do, I mean, every pound you pay, it basically helps us to make sure that we have a really successful class. We're still looking for a house, and this is a call for you guys. I need help because I spent really big amounts of time trying to find a space. I mean, there are some of the doors I can't break through, yes, because I don't know people. If I go from the street level, I knock, like I send an email out of blue, most of the time that doesn't go through the gate holders, and they'll just put my message to junk. So if you know somebody, friendly company and so on, please do introduce me. We'll do all the talking. You don't have to just start the talking, so they are aware who we are and so on, because this way we can make sure that the course continues. Now, we got few weeks before, as you know, we're starting a new course on the 10th of September. So we have a few weeks to get through templates. Templates, there are around 5 to 7 weeks, this introduction to templates. And if we have too much of the delay, we might have to sacrifice templates and then jump to the new course. So if you do want to enjoy templates and if you want to learn more about it, do help me to make sure that we don't lose too many weeks in between, so we can complete that chapter. So, as I was saying, we are, at the moment, this should be actually gone. We are at this module. We are week 4, so basically 1 to 2 weeks, and then we're done. Hopefully, we will go then to introduction to templates, and after that, on the 10th of September, we are going to new course. How we work. I'll go quickly. Tuesdays and Thursdays, we try to meet up. Tuesdays is lecture, so what you're having here. And Thursdays is basically ability for you to try the stuff in practice. So what we're showing you, you have a much more less formal meeting. It's not recorded. You just sit down, you play with the code, you put challenges and so on, so you can progress your knowledge quicker. If anybody needs a license for Sea Lion, do email me. If you don't have my email, I am always on Slack. Message me. I'll give you my email address, and you get basically 6 months license for free from our friends at JetBrains. So if you need license, let me know. If you want to support us, or you know somebody else who wants, that's the best ways. Yes. So 3 ways. Today I'll just talk about this one. When we finish the class, make sure that you go with us to pub, and these 3 guys will get from you, a drink. Yeah? Today, don't worry about the food because we are fed by Mimecast, which is nice. Thank you very much for that. But make sure these guys got a couple of beers, so they'll go back happy and content. But as well, share some of the stuff about us on social media. The more noise is about us, the more interest is in our group, then our work basically becomes easier. Yes, if we very little, then it's really struggle to get people interested. And always obviously check our website. I do try my best to keep the website up to date and put all the information on that website. So please do get to the website and see what's going on there. I try to publish there. By the way, I'll put on my desk in a few moments the stickers. So if anybody wants our C++ London Uni stickers, grab yourself a couple of. And that's all pretty much from me. And I'm passing mic to Oliver. Oh, by the way, if you have any questions, do raise your hand. I'll grab the mic and I'll go to you. The reason being, it's people on YouTube can hear us, yes, your questions, and as well later on the recording. So basically, our recording got much more value because people know what we're talking about. That's all from me, and I'm passing you to Oliver.
Right. Hopefully this thing's on. Should be broadcasting. If you can check the YouTube, that'd be great. Well, yeah, hello everyone. As usual, the obligatory, the feedback slide. Yeah, I do love hearing feedback from you. We get some sort of nice ideas this way. Actually, that's how we ended up doing the little sort of TDD project that we're currently undertaking. But yeah, if you're not on our Slack, then please do get on there. And those who are already here, you know this slide. You should already be on there. So, I'll just have a quick previous lesson, recap of the previous lesson, and I'll try and get through these 2 hours of talking. I'm still slightly under the weather, so my voice isn't quite back to full power yet. Anyway, so obviously, you know, we revised a lot of the concepts. We discussed the basic principles of TDD again. We did, of course, look into mocking. Who's currently feeling reasonably comfortable with what we've covered so far? Got one. A little bit. Okay. All right.
Using an anchor would, I think, would be still a challenge.
Using a what, sorry?
Using an anchor to do it, starting from scratch.
Oh, you see, taking the full TDD approach would still be a challenge to you. Okay. All right. Yeah, so we then dived into some live coding and practicing TDD and mocking, and that's really what we're going to do today. Yeah, it's time for live coding this time. And I just decided to invent a quote this time, which is that the only perfect code is the code that you don't write. Less code you write, the better, right? So, yeah, there is no lecture today. We're going straight into the code. However, if you've not kept up, you missed the lessons or whatever, don't worry. There is a branch you can start working from. So if you're already on GitHub Classroom, I have a call. Tom, would you? Thank you. You can go to this URL here, github.com/cpp London Uni TDD lesson 2, and you can clone it. So if you and you need to check out this branch called lesson 4 specifically. So who would like to just take a moment to do that before we get started? Preferably everyone. Or you'll just be well.
This is if you're up to last class.
So if you follow the classes, you don't need to clone this. If you're all up to date, you don't need this. If you're not up to date, you haven't quite gotten to where we were last lesson, then just you can clone this and check out the branch called lesson 4, and you will then be completely up to date with where my code is, because I literally pushed it about 4 hours ago. So I've got a few joining us, it seems.
Just as an aside, I'm getting a really long time to build one up.
Are you on Windows? Yeah. Get Visual Studio. Don't use, if you use Cygwin or MingGW, it's terribly slow. Right. So, for those of you watching online, I'm just going to take a moment and we're going to try and transition this. So, please do bear with us. Okay, let's see if this works now. Oh, nearly there. Good. Okay, so we're going to pop this into presentation mode. And can we view project still? Yeah, lovely. Okay. Right. I need to switch the view for everyone in the classroom. That would probably be helpful. Mirror. Don't break anything. Please don't break. Okay. Is it still? Oh dear. Okay. Can someone check the YouTube and see if it's broadcasting properly? It should look like this. Looks like that, yeah? Cool. Okay, brilliant. Right. So, where did we get to last time? Well, let's just go through the whole application as it is. So, before I do that, does anyone want to tell me or remind us what it is we're building, first of all? Hmm? Go on. You're the first one.
Well, it's a blockbuster. I don't know how to explain it. It's a blockbuster system for videos rentals and customers videos. It's an
Yep.
administration system, I should say.
Precisely. Yep. It's relatively generic in what we're building, so it will handle sort of renting out anything, but our primary focus is obviously rentals of videos, since it's the sort of a reasonable thing to make. So, with that in mind, obviously we are doing TDD. We've got a couple of classes implemented, and last time, so we have a customer currently. As you can see, it has a constructor that's initialized with the name of the customer and the address where they live. We then have obviously this function to return the customer's name as a constant string ref, their address, the money that they have, the active rentals. We can obviously give them a rental as well. We can take a rental from them by the index of the rental, and we can adjust their balance. So we got through all that, and we ended up on the rental controller. So again, referring back to last week, for convenience, you don't have to do this. I prefer to put the implementation in the test file, and I'll only move it out once there's really a large enough body of implementation code to warrant doing so. So just to double check again, who has got the code base checked out? Yeah, cool, okay. Right, so obviously we finished this test previously, right? So we verified that if we pass the iRentable interface into our rental controller and we call, via issue rental, it would correctly rent it out. And it's obviously a big part of mocking. So we'll just go through this sort of line by line, really. So we construct our rental controller. This is the class we are testing, right? We're going to test the rental controller class. And then obviously we need to create some mocks in order to actually verify it does the correct thing. So we have an instance of our mock rentable class. So if we want to take a quick look at the mock rentable class, you can see here, it's, I've just called it mock rentable. You can call it whatever you want, but I think that's a sensible name for the class. Obviously, it needs to implement our interface. And then we use these macros, which come from Trompe-l'oeil. And these allow you to obviously create the overrides. So if we were to look at the real interface, because the interface is obviously, part of the production application as well, it's declaring the virtual member functions. They're all, of course, what does this mean? Anyone? What's the equals 0 mean? Pure virtual, thank you. So they are not implemented in the interface because, of course, we're treating it as an interface. And then, of course, the virtual destructor is to ensure that if we destroy it as the base, it's correctly clean. The implementation is correctly cleaned up. So I was chatting with a friend about this, and when he was going through the session from last week, he actually realized something that I didn't think about, and something that we should probably address. And this actually sort of comes down to the fact that we're not unit testing this class, and we probably should have. So can anyone see something wrong with this class? Precisely. If you add the pence, Tom, can you close the doors? Yes, exactly. So we need to actually ensure that the quantity of money that's in there is not. Once you have 100 pence, you want to wrap around, right? So in true sort of TDD fashion, we're going to actually create a test for this before we move on. So we'll have a source file in the test folder, of course, and we'll call it, well, test money, yeah? It's like play money, but not quite. So first of all, we need to include our class, of course, money.h, and then of course we need to include catch2. And we shouldn't need a mock for this. It should be enough to unit test it, right? There's nothing to really mock, is there? So I suppose a simple one would be a money class with, let's use lowercase, let's say £5.14 plus £1.99 returns £7.13, right? So does that make sense to everyone? Yeah? So what's the first thing we're going to need? You need to, so we need to construct an instance of the class that's got £5.14, yeah? Correct. So money sum £5.14. Is everyone clear on what that line's doing? You have the constructor, 5 for the pounds, and just to make it a bit easier, you know what we'll do? This, I'm actually going to gut it. So, or I won't gut it actually because it will crack, it won't compile. So just to be, let's copy it instead. We'll go here, and I'll just have that instead for now. We'll paste it back in when we're done. So just makes it a bit easier. So can everyone see what that's going to do? It's going to construct it pounds and pence. Does everyone see how it's essentially aggregate initialization? There's no constructor, right? Does everyone understand why it works without a constructor? Sorry? No, it's not actually. There is a default constructor, but it's not. We're not using that because the default constructor obviously doesn't take any arguments. Yeah. Why does it work? Precisely, it's because the pounds and pence are public, so we're just directly initializing them from this here. This is actually slightly, arguably bad, because if we default initialize it, if we do true default initialization, what will happen actually? Go on, I'll leave it to the floor.
I know people say you are grown up, so we shouldn't have
Does anyone know what will happen if I default? So everyone's clear on what I mean by default construction, right? Yeah? Oh, let's call it def. And I say return, how much will that return?
0 and with char it will be default.
You think it will return 0?
No, it will be undefined behavior because you don't have any values in pounds.
Precisely. It will be undefined behavior. However, it's not because it's public that that's going to happen. You could.
Just to expand on that, if instead, where it says money debt, you put empty pair of curly braces, what would happen? Then you get zero.
First answer?
I think then you get 0.
Yes, you would.
You get what's called value.
So if you put an empty pair of curly braces, then you get what's called value initialization.
Yes, precisely. Or we can obviously default initialize them up here, and then it's all fine.
The two
So
things.
we'll leave it public for now. I don't think we have any necessity to mess around. So, of course, we now want the addition. So sum plus plus equals a sum of £1.99. So does this make sense? Hope so. We're adding a temporary instance that's got 199 in it, yeah? And so what should we do next? done the addition. What next?
It's correct.
Yeah. Jonathan again there.
You need to check that it's correct.
Yes. So we're going to require.
Shouldn't first fail.
Sorry.
Shouldn't the first check
Well,
fail?
we're doing the check. I didn't say whether it would work or not, did I? So I want the sum to be £7, obviously, right? And actually, I won't use require. We'll use check because it's not fatal. If it's not, we don't need to terminate the test. Can you guys remember what the difference is between check and require?
Check will continue. It's not like dead and ending the program.
Yes, check will continue running the rest of the test. It's still considered a failure, but it will at least continue trying out other things. So require is like, oh, don't bother checking the rest. It's done. So. Pence should be 1 3, yeah? So, looks reasonable, right? So we can now run it. And once it builds, well, it failed. And because we use check and not require, it will verify both of them, and you can see both of the failures. So we see that the pounds was wrong, that's off by 1, and the pence was wrong, because because it's a char. Does anyone know why we had Q pence?
Convert to the int. It's
Because it thinks it's character. It actually thinks the value is a character. So it's a bit. Oh, come on. It should precisely. It is. Sorry, wrong value. We'll just static cast it just to get it to look nice for now. So if we do it again, now it's not going to say Q, right? Yes. So obviously we need to essentially correct our plus operator. So Tristan over there.
Just being difficult, really. But out of curiosity, why are you using signed values instead of unsigned values? Because unsigned might not do the conversion.
We're using signed values because obviously operator plus equals should still work with a negative sum of money.
Okay. Negative pence.
Why not? I could have minus 1. I want to debit you on £1.19.
Oh, okay. Fair enough.
why do we use char for pence, not int?
It's a sort of micro optimization, really. But what's the maximum number of pence we're supposed to have?
100. That's the maximum. No,
No,
99,
that's
sorry.
99. What's the minimum?
1.
Minus 99. Right.
It's
Yeah.
not signed.
Yeah, of course it's signed. Char? Yeah, char is signed. It's implementation defined with char is signed.
Yeah, you have to use signed car, which is a different type to car, believe it or not.
Ah, yes, you're right. Well, I happen to know it's signed in this case. Well, yeah, in the interests of strict correctness. I don't know, how do we feel? Sorry?
Isn't the car there actually a bit misleading? Isn't the car having a car there a bit misleading when you put equals 0?
Why?
Because isn't it equal? Aren't you saying it's equal to actually the character 0?
No, that's just the numeric value. It's just a null. It's just a null. Or int 8t. Int 8t might be reasonable. I'm inclined to go with that. Is that's the same as it? It is. Yes, let's use that. So. Who's got the microphone? Oh.
Okay, so my question was, why do we use char instead of, for example, int or short?
So we're not using it because we don't need more than 100, so there's no point. But I think, is there an int 8t in this? Yeah. We'll use int 8t. Better? Better. All right. So
Also, why aren't you using the when then catched?
Why am I not using what?
In catch, you can have when then that.
You mean given when then?
Yeah.
That is BDD style. We will breach that, but we're just keeping
Okay.
to simple test cases right
Cool.
now. So, let's actually write some code. So we want the bare minimum code to pass this. Let's not get too ahead of ourselves. What can we do to fix this in a general way? I'm not gonna say that we should just say pounds equals 7 and pence equals 13. That would be a bit silly. So what do we want to introduce to fix this?
Check whether it's greater than 99.
So you're saying check if. Go ahead.
I think you need to check whether it's greater than 99 or
It's a
less
valid
than
way of doing
minus
it.
99.
So it's greater than 99. Do what?
Return pound.
No, 0, take away 99 pence. And you're just doing.
Can anyone think of an easier way to do this? It would work, but there's a much easier way.
Drop
Not quite, no, you
the
don't need a bit shift.
drop the pence to 0 and increase by 1 pound.
Well, I'm saying there's an easier way without actually going into the if. Go on.
We could use the modulus.
Thank you.
of
Modulo,
100.
yes.
Mod-
Thank you. So go on then. What am I doing with the modulo operator?
So you would do pens modulo 100. That would give you the.
So, well, do you want it in a temporary? What do you want to do with it?
That would be best to do. Now you can assign the temporary or add the temporary to. Well, you don't even need that temporary. You can just pounds plus equals pens modulo 100.
Mm-hmm.
And now you also need to subtract that from pence. So pence minus equals pence modulo 100. No. Yes, modulo 100 times 100. Well, yes. That would be probably easier to do. in different
Okay,
way.
so, or you could just do pence equals pence mod 99, no?
Yes, I think so. But then you can't take care of the already operation you did, so it's slower.
Actually, is this going to work?
Pence modulo 100 is going to give you
The remainder, yes.
Pence modulo 100 is going to give you the remainder after dividing by 100. So what you want actually is integer division, floor division. So you want pence divided by 100
Yes, that's actually correct.
there. And then the second one is when you want pence.
This is mod 100, that's
Yeah.
the remainder.
and the-
Yes. So you want the floor of it, right?
Well,
so
no, just pence divided by 100, you'll get int division.
is that that's guaranteed to be floored, isn't it?
Yeah.
Yeah. So
Round to 0, I think, yeah.
So divide that one by 100, get the remainder for this one, and we should have it, right? Let's run the test case. We're not there. So it's obviously getting 5, right, should be pounds is 5, that's plus 6. Pence is going to be overflowed. So what did it end up with in the pence? Let's see. Nope, it's exactly the same. Let's just run this again. It did compile. It should have. It definitely has compiled. Sorry? No, it's in range. Ah. Right, we're not including it. Say again?
Division has quite high precedence, so just try putting it in brackets. I don't think it'll change, but no, the pence divided by 100.
I've got fail 14 equals 13.
You got 14 equals 13.
Maybe I just can't do this anymore. Yeah,
Well, what we can do.
Try putting that right-hand expression in brackets there.
Sorry, do you mean
Yeah.
the
Just like that.
okay.
Might not change anything.
But it's
No, it doesn't. Never mind.
it doesn't change it. No, I wouldn't expect it to.
Just want to make sure it is a floor.
Do you want to make sure it is a
Yes.
floor?
Well, let's see. We're gonna have. Let's see. We're gonna have £6. We still have £6, so that's right. But no, something's wrong here because I don't. Is it recompile? Is it not recompiling? No, it is recompiling. We still have pence. Ah. So if we take this mod 100 and it's 114 and it's 113, sorry. Yep.
No, ignore me.
So we're still getting 113. Let's just do something silly, right? Let's do pence equals 13, right? At least we'll know if that works. Well, something's completely broken here, isn't it? It's supposed Sea Lion is supposed to save the file automatically for you. I shouldn't need to.
I've got everything working.
Well, we know for a
I haven't got money age class in my test.
sorry.
Isn't that taking the...
That shouldn't matter. This is a separate translation unit. No, there's something wrong with the comp. Right, let's figure out what's wrong with compiling because obviously Sea Lion is not compiling this.
Isn't that by any chance taking the class of the other file?
No, because then there would be two definitions and it would just not compile. So, what is going on with my Sea Lion, everyone? What is indeed going on?
You want to just change the compiler and see what happens?
No, it's not the compiler. The compiler's fine. So let's just try something silly. So it would seem something's going wrong. This. Sorry. Yeah, let's try cleaning the build. Let's do a rebuild. Come on. Okay. No. I'm just gonna let's just. I'm gonna. I'm gonna check. No, it's not. It's compile related. It's not that. So. Oh, hello. Yeah, I just did that deliberately. So what I'm now trying is I suspect it might be linking the wrong thing. So if I change all the symbols to 2 Ys, let's see what we get. So yes, it's picking up the wrong. It's picking up the wrong class. The wrong struct. Between the translation, well, there's one definition rule in the translation unit, obviously, but in the entire linked binary, there's not. So I don't really want to work with this being named in such a way because that's horrific and ugly and going to take too much time. So as a simple way to fix the violation, we'll just stick it in an anonymous namespace, and the problem should have gone away. So, well, I could, but the point was that it's going to be annoying for me to do this session because I have to keep switching between files. That's all. So, if we remove this, hopefully we've got a passing test case and no ODR violations going on. Hooray, we did it, everyone. So, who would like to suggest our next test case? What's a sensible one? Thank you, subtraction. Tristan would like to suggest a test case?
Well, it just seems that you perhaps want to test construction with £5 and 123 pence or something.
So ensuring that adding a constructor, ensuring it correctly clamps it. Yeah, I agree with that. We'll do that one next.
Make sure that somebody doesn't pay with unsigned value. So I pay you minus £20.
That's independent of the class, right? This is just for the programmer to use. This is the purpose of this struct is for the programmer, not for the user, right? There is implicit trust of this class. I implicitly trust whoever uses this class is one of the developers working on the project, not some outsider who's going to attack my system. They can't use this code, right? Make sense? So we'll have our sum again. So this time it's £2.45. And we can just add the negative values, right? So minus 0, well, minus 0 is 0, obviously. Minus 46. And we can check sum.pounds is equal to 1. And we can check that sum.pence is equal to 99. And of course, I'll just static cast it so you get a readable result. Come on. For some reason it's being very laggy. Okay. So, does that all look reasonable to everyone? Can run this one now. And, well, doesn't quite work, does it? Does not quite work in the case of subtraction. We end up with £2, that's fine. But we also end up with, well, minus 1 rather than 99. So, got a slight problem here, haven't you? Working in the opposite direction is a little bit more tricky.
If you have positive pounds and negative pence, you probably have to make sure this lines up again.
So, actually, no, I'm just going to make this a little bit more complex. So,
How about convert everything to pence?
sorry?
How about convert everything to pence and then subtract pence and then split this back to
So
pounds?
you want to refactor, you're suggesting we refactor the entire implementation to express in terms of just pence and extract it out. But then we've got to divide by 100 all the time. They're separate units, right? I think we'd like to keep our separate units. It's a reasonable abstraction to have these separate, but we essentially need to clamp them, right? So at the moment we've solved for, we can take the number of pence left, divide it by 100, you get whatever you get, right?
Basically, inside the class, convert this to all the pounds to pence, add them together, do all the operation, then the result
Yes, I
split
understand you.
basically between pounds and pence.
Yes.
So
I
this way we
understand.
avoid all sorts of traps.
We do. We also, however, and I'm trying to make this a bit more interesting. Yeah, we do, but it also means you lose. You can't have as many pounds as you otherwise could. It's basically 100 less than it would have, or it's a factor of 100 less than you could have right now. Right, the maximum number of pounds I can store in a long, right, is obviously greater. If I represent it all as a long, I've lost a factor of 100. It is a lot of money.
So
actually.
much,
It
so much
literally is.
money in a grocery store. You're very lucky.
In the case of the, well, okay, so whilst I do agree with you, Tom, it would be simple, and I don't think you'd need to account for 2 to the power of 64 pounds anyway. Let's be honest, that's like more than the GDP of the entire planet, I'm sure. Yes, exactly. So it's not happening. So essentially, yes, you're right, but I don't know. I think it's going to make it too easy. I'm going to leave it contrived, and we're going to keep them separate, just because maybe we do need that many pounds. Who knows? Maybe hyperinflation will kick in, and we'll all be, spending £1 billion on a loaf of bread. So if you can't think of a clever solution, we can always just do a simple solution and refactor. But so for Parvez who's just joined us, we currently have a passing test case where we can add £5.14 and £1.99. We get £7.13. Right, does the correct adjustment. But if we subtract 46 pence from £2.45, we don't end up with £1.99. We end up with £2 and minus 1p, which is strictly speaking correct.
Well, adding if-else statement before line 15, is it easy enough? Or it's
So you would go with an if else?
if
Perfectly valid way
pence
of
more
doing
than 0, we do this logic. If it's less than
It's a-
100,
it. Okay, so you're saying
if pence more than 100,
pence is more than
100,
okay, so you're making it entirely conditional, which is okay. It means if it's not over, then we don't have to do anything at all. Yeah.
else we do the logic
Just else.
else if
Else
it's
if
less than 100 and more than 0,
pence is
less than 100,
well, it's definitely less than 100.
well, more than 0, then
More than 0. What do you want to do if it's more than 0?
well, is it possible that pence could be less than 0?
Yeah, it is in this case. Look, it's minus 1. You know, a negative. We have a negative amount of pence. So what we really want to do, right, is we want to check it's less than 0. And then we can have some special behavior if it's less than 0. Make sense?
That,
If the value of pence is between is between 0 and 99, we don't need to do anything to it. It's fine. Right? If I have £5.50, that's fine. I don't need to do anything. I don't need to manipulate the value any further. But if it's less than 0, if it's negative, now I need to do something. Sorry? I need to decrease the pounds, yeah. So pounds will be less. What exactly? What if I have minus 200 pence? Sorry? Same what? But negative, you say. So you're saying I can just do pence divided by 100? The pence is minus 1. What's minus 1 divided by 100 when it's floored? 0. So that's going to do nothing. So it can't be that. Sorry?
minus equals
Well, but I'm saying what if I have minus 200 pence? I'd need to take off £2, not £1. Well, sorry, I mean if I had minus 1p, I decrease it by 1. If it's minus 101 pence, I need to decrease it by 2. We can't just be minus equals pence. That's gonna. So. So what do you want to do? So minus pence. You mean this? So that's now going to be 1 divided by 100. What's that going to be when it's floored? 0 again. Still 0. Yeah. Nobody got it?
Well, I would do the minus pence. I would divide this by 100. That will give us
0.
the number of no.
Yeah. The pence is minus 1, right? You can see there in the test. You have minus 1 pence. If I divide it by 100, it's just going to go to 0. Say that again? The ABS of minus 1 is 1. The ABS value of positive or negative 1 is 1, yeah? Yeah, ABS removes the sign. So the -1, if I ABS it, will become +1, yeah? 1 divided by 100 in flawed math is still 0.
We had to add 100 to any number and then take modulus.
Oh, so you're saying add 100 to it. So if it's 199 minus 199, it will then just become -99.
Yeah, so minus pence.
Convert from minus pence to plus. Is there any ideas on YouTube? So let's take let's just take a simple approach to it right now, yeah? We currently have -1. We know we need to decrease by it, but the problem we have is that if the units are above 100, right, we need to essentially isolate that part of it. So if I have 199, minus 199p, right, or minus 101, that's £2 that I need to come off and change. Sorry, Tristan's got something.
I have to feel, I think I agree with Tom that it would be better to just have an internal representation that stores pence, because otherwise you get odd things where you could,
I agree it's better.
You could construct a money with -£2 and -46 pence, and what does that even mean?
I do agree that it's better, but this was mostly to add a little bit more challenge. But if it's too much, then we can simplify it. All right, we'll go for the minimal. We'll go for the minimal solution. Let's just take it and say, so if it's less than 0, we can take. Well, actually, let's see. If we've got £100, if it's 101, we need to isolate the top level, so we could take the modulo of the pence. So yeah, no. So we're dealing with the pence. So imagine this, right? We'll say that. So the overflow, right, you need to check for first is essentially the pence mod, no, not mod 100, divided by 100. So in the case that it was 101 pence, then it would end up being -1, right? So we can actually just do that there. So we can say pounds is less that value, right? But then, of course, if it's less than that, it's going to do nothing. Yeah? So if we then have, say, -1 or -99, that's the final value we then need to massage, right? So we can subtract by that first. We can then say pence equals pence divided by 100 to take off. Actually, no, we don't want to say equals it, does it? No, it's the remainder, so pence mod 100. So then that would give us the -1, right? And then pounds is going to be, it's going to be conditional, isn't it? So essentially, if pence is greater than 1, sorry, if pence is 0, we do nothing. Otherwise, if pence is still less than 0, we need to do something. So there's probably a better way of representing this. But basically, if pence is still less than 0, then pounds minus equals 1. Then, of course, we need, now come on, you can figure this one out. So we've done most of the work now. If I have -1 pence, what does it need to actually be turned into? What positive value does it actually need to be? Add it to 100. So pence plus equals 100. Who reckons that will work? Nobody. Who reckons it won't work?
It's a basic math, guys.
Yay, we did it.
Test case where you go into negative pence.
Sorry?
You add a test case where you go into negative pence. So you end up with -1 pence.
Yeah, I like that. Actually, well, yes, we'll do that one after Tristan's, because Tristan was next in line. So you said Tristan what? The constructor, right?
Tristan?
Well, actually, if we do the constructor, we've basically solved it, because now
Okay.
it will be forced to fix. Well, go on, we'll work through this. We'll do yours first. Go on. So a money class correctly. What is it you were looking for in this test case? How do you want to word it?
If you were to construct a money with £2 and minus 45 pence, what does that come out as a representation?
If you write what? Sorry.
If you construct a money, say, with arguments of 2 and minus 45,
Yeah. That doesn't really look right, but
exactly. So if you were to pass those arguments to the constructor, what would you get and would things work? Should it resolve to minus £2, minus 2 and 45?
I see what you're saying. Yeah, you have inconsistent signs, right?
Or 155, yeah, what should it be?
So I think I'm gonna make the case that it's undefined behavior for the programmer to use this class and pass different signs for the values. Okay. So if we can add a unit test actually that will make it throw an exception if you do that. So I'm gonna require that either both are positive when you construct them, or both are negative, but you cannot mix the sign. Okay. So we're not allowing a user of our class to mix the sign.
So if you put, let's say,
Minus £1.45, that will be treated as a one figure minus 45. Or
So you must put both values negative, right? You can't mix and match.
What you could actually do, couldn't you, is rather than having your money case, could have a third, so you've got pounds, pence, and sign as
Yeah.
part of the class.
Sorry, I'm distracted for a sec. My Mac is discharging, and that's not a good thing. Right. Hold on. Plug it. No. Just plug it back in. I have a working theory. There we go. Okay, it's working. So sorry, John. Was
So,
it?
yeah, I was just saying that what you could do to take your idea of having pounds and pence is actually have to sign pounds and pence as part of the definition of the class.
Assigned.
So you put in £2.23
Yeah.
minus £2.23.
Oh, you mean that you take three arguments essentially? You have the sign, the value. Ah, yes, that's a nice expansion. I think we'll stick with what we've got. But yes, I like that too. So essentially, you see we've got £2 and 123 pence. Should become £3.23. I think that was Tristan. That was your original idea, right? We're going to massage it essentially. No, it's not. This is not the sign though. This is purely just fixing the numbers up, right?
Yep, sure.
Yeah, okay.
Yeah, that sounds sensible, doesn't it?
Okay. So £2.23 and sum plus equals. What was it? Actually, no. There's nothing to do. There's nothing else to do. Just check sum dot pounds equals 2. Sum dot pen. Pence is 23. That's not quite a right test though. It should be £3. Right. So basically now we need a constructor, don't we? So I'm going to make a constructor. And you guys are going to love this. Tristan, you know what's going to, you know where I'm going with this, don't you? No? Don't say it. if you
should we apply default values?
Sorry? There's already default values. It's one of my favourite things about C++, that actually we're fixing it, so it's not that bad. So obviously we'll just keep the existing stuff working first. Come on. Okay. Has anyone got a really bright idea of how we can actually fix this with essentially like no effort at all? I say fix it, I mean fix the test. So just to make sure it should fail, right? So we'll just run the test real quick. And yes, it fails. 2 is not free, and 1, 2, 3 is not 23, so it didn't do anything useful, right? Can anyone think of a super duper simple way of making the test pass? So, adding code to this constructor.
Just shift the code into the function.
I could do that, but I'm not. I don't want to move it. What else could I? Come on, it's really silly.
Add 0, 0.
Precisely. It's basically just going to call it, isn't it, and fix it.
Yes, are you going to recurse into your constructor?
Every time you call a money constructor, it's going to call a money constructor.
Yes. Yes, our own constructor is going to recurse infinitely. Well, actually, you right. Yeah. Do you think it will do that at the moment, as it stands, as the code stands? Is it going to just recurse infinitely? Turns out it doesn't. Oh, sorry, no. We segfaulted. Sorry, yes, we segfaulted. Should we have segfaulted? No, but should it have? I'll get to what I'm thinking of in a second. I'll get to what I'm. No. Obviously, this line, you're right. That's not what I'm getting at. But okay, I'll tell you. I'll talk about it in a second. Yeah. So we've essentially got our own constructor. What's a simpler way around it? Precisely. However, we of course don't have one because we overrode it. Reasonable. So let's run it. And we fixed it. And so the thing I was going to get into actually, which it turns out does work, is does this not result in aggregate initialization anyway, because it's still public? Which
Now you've added a user-defined constructor.
does that now work? What was the case where it
It
did?
was where you had a user-declared but not user-defined constructor. So if you took away
Yeah. So if I
I knew what
separate
you were
it,
looking at, but-
if I separate the definition from the declaration.
No, 'cause as soon as you've got the second constructor taking 2 arguments, that's no longer an aggregate.
Okay. So we are safe.
Yeah.
So, yes. So probably in the interests of fixing this of cleaning this up, we should probably just make these private, really. But sorry.
Yeah, the constructor that you have, default initialization from
These.
yeah, and then remove the default constructor.
Oh.
No, you get the recursion.
No, you were suggesting what we've done. You were suggesting that. Sorry, not that.
Yeah, it's recursion. Okay.
Yeah, but it's going to be infinite recursion, isn't it?
Yeah.
Could just add, we don't have 0, 0.
Sorry.
We could just run the add operation if we are not at 0, 0.
We could.
We check if pounds equal zeros and pence equals zeros, then we don't do the plus equals.
Pounds can be equal 0, pence not. Actually, no, sorry. One of them needs to be not equal to 0.
I think we'll just go with what we had, right? It was
You can have
perfectly fine.
£1
We can
and 0
explicitly
pence,
default the
or
default
one,
constructor,
let's say p or whatever,
and
and £0.
then we are left with the types. That's fine, right? It just calls the default constructor up here. It's default initialized to 0. It does what we want, right? We can worry about refactoring it later. So,
We set up a test.
Where we check that pounds and pence, both of them are not equal to 0.
what's the purpose? Why do we need that?
Well, if I pay £0 and 0 pounds and 0 pence,
Yeah.
yes, then it's logically not really good operation.
But that's not the responsibility of this class. This class is purely financial. If I add £0 and 0 pence, this class doesn't care. It's a mathematical class. If I... well, not really, because I have to add a check, which introduces overhead. Adding the check is overhead. That doesn't make it faster, that makes it slower. Because now I have to check a condition. If I don't have to check the condition, it's great. No, so if you use this class, you might want to check that you're adding 0, but it's not the class's purpose or job. Yes, go on.
Does this work correctly at the moment if we add 99 pence and 99 pence? Because wouldn't that
a good
overflow
question.
right away?
That's a good question. I believe it will, but let's try it. Money class correctly adds Everyone agrees with me on my answers there? Check. Yeah, I'll do it, why not? Alright, well, it should be £1.98 if I'm not mistaken. Who thinks it's going to pass? Who thinks it's going to fail? Hands up for pass. He thinks it's going to pass. John thinks it's going to pass. Tom thinks it's going to fail. Okay, those of you who didn't put your hand up, I'm assuming you think it's going to fail. Well done. And of course, we've got a negative number of pounds. We've also got completely messed up number of pence. So this has gone a bit haywire, hasn't it? So obviously we can assume we know that this should initialize correctly. Well, let's just make sure it does, right? Let's take an old test and just make sure we didn't hose that completely. Yeah, that's still fine. And that's still fine. So we haven't broken any of the existing tests. So I should point out, actually, it's better if you run all your tests as you go. Sorry? So this failing test, right? What have we done? So let's step through it, yeah? So we have 99 pence. We're going to come here, we're going to add, well, that's going to be 0, so that's just going to stay 0. And then this is going to end up being 198. Sorry?
Type isn't big enough to contain the sum of the maximum of the lower type.
Yes, it's going to end up being 198, except it's not, because it's signed integer overflow, which is undefined behavior, although technically it's not really going to do that to us. And yes, we've exactly ended up in a situation where we have, in fact, overflowed. So, okay, come on. What's the easiest way to fix it?
Int 8, just change to int 16.
Make it bigger. But what's more, does anyone want to have a go at a more interesting solution if you don't change the size?
Check for we don't go over the
Size, and then split.
So we can check we don't go over the size, yeah. But I think we're doing this to death, so we're going to take the easy option. Boom, we fixed it. Amazing. So if we run it, of course it passes. Of course it passes.
Question was there was 33,000 pence.
But then the point, that shouldn't matter, right? Oh, I should fix the constructor. Well, actually, I probably don't want to fix the constructor. Really. No, because this will just be plus 0.
No,
till add 2 basically in 16s at the maximum positive value and end up with the.
Oh, I see what
overflow
you're
again.
saying, because we're now
So if
allowing
you
you
do-
to overflow that, yeah. Yeah, you know what, we can, anyone who's using it has to stick to a reasonable value. So, essentially, yeah, that's safe now, isn't it? Right.
You get that.
It's a bit of a lazy fix, but it's nonetheless a fix. So, are we calling this useful? Are we ready to say this class is good? We could do a little bit of cleanup.
I still want to add the test case. What happens if you got 10 pence and subtract 30
Oh.
pence?
So, test case. A money class, money class correctly subtracts, I shall say calculates. So you said how
10
much?
Pence minus
So how much?
10 pence
10 pence positive
positive
minus,
30 pence negative.
okay, to minus pound 0.20. Yeah? Alright, so we have our sum of 0 and 10. We can say the sum is plus equal to of, come on, actually, no, it's 10p minus 30p, so it's minus 20p.
Yeah, but he's passing minus 20 to 10.
Sorry, what?
Minus 30p.
That's 10p.
Plus equals money needs to be
That's-
30.
Oh, sorry, yes, it needs to be 30, yeah. Right. Nope. So we end up with minus £1 and 80 pence. Oh dear. Okay, so we've got another test case. You might as well fix it. So, how much time have we got? Oh, we got some time. It's only 8 o'clock. So, well, let's step through what we've done, right? So, we start off with 10p. We take away 30p. So, these are zeros, so that's all fine. We then will end up with minus 30. And essentially, what we've really done is we've assumed that the value is basically just always going to be positive, needs to be sort of positive, effectively, right? So the pence here will be less than 30, less than 0, right? It will be minus 20. Sorry. Or couldn't we just say if pounds is greater than 0 and
If you are still, if you do it the same test but add £1 to it,
what do you mean?
so this is still not going to fix it.
Hold on. So do you have a test case in mind? Think of a test case. We'll do TDD, so we'll do it TDD style. So let's make sure we haven't broken any tests. I'm just going to run everything, and run the whole program, please. Yep. So what's your proposal?
My proposal would be at the plus equals money would.
So how much do you want? So what's the starting value?
No, actually, you're right.
No test case? You can try it anyway, just for confidence.
No.
No? Okay. Can anyone think of any further test cases that now makes this, could break this, make it misbehave? Because again, TDD doesn't make your code perfect. You have to think of tests.
What if we pass something that's not a number?
It won't compile. That's not going to compile, clearly. It takes It takes a long and it takes an int16. You can't pass something that's not a number. Oh, yeah. So that's, yeah, no. Any other ideas? I'm very much just kind of just asking myself here. So
0, 0, 0, 5 or something.
you mean a floating point value? Well, it'll just be 0 because these aren't floats. That's not. That doesn't have fractions. Only double and float has fractions.
What if we put a value that's, if we add them together, pounds and pence and pounds, they will go into overflow. I mean, overflow. Yeah, overflow.
So yes, you can overflow this class. You absolutely can cause an overflow. That's not something we're going to try and tackle. Or maybe, I don't know. Do you guys want us to try to tackle signed integer overflow / underflow? We can write a test for it. What should we do? If we want, so logically, right, you could say that in the event of us doing something that would cause an overflow or underflow, we can throw an exception. We can simply ignore what they're trying to do and leave it at the maximum value. Staying at the max value is sensible. Throwing an exception is probably nicer.
We could put certain value and say, if you have this much cash, you are those Bill Gates or Jeff Bezos. Otherwise, go away.
You have hacked the system. Go away. Yeah, there's many things we could test for. Well, are we going to deal with? Do we really want to deal with the overflow of the pounds? I don't think we really care, do we? I'm not sure if anyone here is. Hmm? Of course, you can always do an if statement. I think we can get a little bit creative with this rather than trying to focus on more issues. I think we've basically got a solid. Oh, go on, Tristan, you got something?
I was just going to say that sort of as a kind of teaching point more than anything, it's always good practice. So at the moment we've got an equality operator and one of the compound assignment operators plus equals. So if you were going to use this class in real life, every time you have an operator equals, you always want to have an operator not equals as well.
I agree.
And if you've got a plus equals, then you want a corresponding freestanding operator plus, and you want a minus equals, and you want a freestanding minus, and you probably even want a unary minus as well.
Oh, what, sorry?
A unary minus as well.
Yeah.
So probably not worth doing just for this little tip, but just
so
sort of to bear in mind if you were going to do something like this in real life. You want a complete set of operator overloads. Do them all.
So I'm not going to disagree with you per se. If you're building it for other people and not yourself to use, then absolutely, they will probably expect it. If it's part of your development process and you're literally building it out just for you to consume, don't bother. Add operators as you need, because obviously by following TDD, you will need to add tests in order to justify those operators. So in particular, this is obviously a class just for us. We're not releasing this as a library for someone. It's just our code. Consequently, we're not adding more operators.
That's what I meant by doing it in real life.
Yes.
If you're,
Okay, I got you. Yeah, so since we're TDDing it and it's just for us, we're not going to implement all of them. If we were releasing this for somebody else, then yes, we would not only write all the tests for those operators, but we're planning to release it, so it would make sense. But in this case, we're not, so we don't care. So, or at least unless we discover we need it, then we will. So let's do a little bit of refactoring.
Yeah, a way if you can refactor is just add a test case for operator equals, and then remove all the checks for pounds and pence, and just check that with constructed money value.
So check what, sorry?
So if you add a test for operator equals to make that is safe-ish.
So yeah, we can do it. You know what?
Replace all the checks where you check pounds and pence after each other. You can just make that in unison using operator equals.
So I get what you're saying. So we might as well just do it, right? 12.99 equals 12.99. Why did I put it there? and check that money 112 equals money 340 equals false. I'll call it operators. And should pass, right? I've got a warning on this one. Is that, we did fix it. It's good. That's basically. Interestingly, does anyone just look at this? It's telling me I can simplify the expression. Does anyone know why I can't? I know you know. Because we don't, yeah. So that's actually interesting. This should be because this should be a suggestion from Clang. Very interesting. Let's just make sure I'm not crazy, but I'm pretty sure it won't work. Come on. Yeah, I am correct. So, right, we've got comparison scenario. How can we? What's some nice ways of cleaning up this class? Anyone got any suggestions? Maybe a good start would be to make this private. I think that's good practice, isn't it? So, is everyone following along fine so far? Nobody's got lost and needs to catch up. Okay, good. So, we've now separated those, but now we've just made all the tests fail to compile. So, obviously, what we need is we'll have some excesses, right? And we'll just incorporate those. And we have no other way we can't avoid incorporating them precisely because, well, it won't compile till we fix it. So, we can have long pounds. I'll use a capital P. No except. So that's one getter, effectively. And int 16t pence. Let's make it consistent. Everyone understand what those are doing? And the everyone, you can tell me what the purpose of the const is.
So it doesn't change the values?
What does it specifically mean to put const on a member function? What power does it grant? What limitation does it grant?
The method won't change any of the instances member variables.
Essentially, yes. Usually, there's one exception to that, which I'll get to in a second. So that's the limitation that is imposed. What's the power it grants? What power does it grant in terms of using the class? What does it let you do? What's the purpose of it?
You can use the method on const.
Precisely, yes. If you have a const instance, you can still use that method, which you can't do with non-const. So, however, yeah. So you were saying, that it won't. It basically guarantees it won't modify any member, right? There's a way around that, though. Mutable. If I do that, I can modify this from const member functions. Generally speaking, don't do that unless you really unless you're doing something like multi-threading and you're using locks. Don't do it. Don't use mutable. So we have no excepts. What does that mean?
Exceptions.
What do you mean? What do you mean we won't throw exceptions? So go on. Who was saying? Come on. Someone must have a guess.
I mean, because they are long and int, so pretty much there is nothing to throw there. Really.
Oh yeah. Okay. So that's true. But what would happen if I did throw an exception?
It would not react to that. No, it would.
This is a more interesting question. Obviously, if let's say I did something. No, I just did throw, stood, runtime error. Oh no. So ignore the colouring. I haven't included the exceptions, but sorry. It will compile. It will compile. Just to prove it, come on, get out of the way. So if I include that, that will happily compile. Matt. Oh, come on, you know. Someone else.
Tristan.
Tristan obviously knows.
We just die.
Parvez says it will just die. Can you? What do you mean it will just die? How will it just die? Will it crash in a horrible way, or it will terminate? Specifically, terminate how? Terminate in what way? Thank you. It will stud terminate. Yes. So by putting no except, you as a programmer are guaranteeing you to make damn sure that no exception is thrown. Otherwise, the compiler will send you to stud terminate. So, okay, so we've got some excesses now. Obviously, I need to make this clean itself up. So, come on, so laggy. So I think if we just copy this and we can go through them. So,
How about
okay.
do it other way around?
Paste.
The uppercase to the privates.
Thanks for that. Sorry.
How about do the other way, the factoring? Make the private members uppercase and the public.
It wouldn't help because I still have to put parentheses on it. So either way, it wouldn't save me because I still got to make a function call, right? So it's okay, there's not many of them. So first part of our refactor, we're just calling pence. And again, no behavior should change as a result of this. So it should all be fine now. So a second thing we should probably do is, has anyone got any suggestions on cleaning this up? This chunk, because at the moment, right, we call this in the constructor and this plus equals, and that's basically a mess anyway. So who's got a suggestion on a nice way of segregating this stuff so that we don't call plus equals, but we don't also end up copy pasting code?
Separate class?
This is obviously, I'm asking this question as a matter of design now. This is obviously less about TDD and more about just coming up with a neat way to organize your code. So what's your
Separate class?
no, we don't want a separate
function.
Separate function, Tom says. Okay, so what should go in the separate function? What should I call the function? What should it do?
I would say, I don't know.
You could do the pounds plus equals pence over 100 pence mod. You could put the pence over 100 pence mod.
So sorry, which line are you talking about?
Those two lines you've got.
These two lines. I can do what?
And then pass a minus or positive flag, depending to either do the plus or the minus.
Sorry, I'm not following. Go on. Say again.
So you've got the pounds. The only difference between those two lines and the two lines in underneath the else if is the minus sign.
Yes.
So if you call a function with those two lines, there's two similar lines on, and just pass a flag to see whether it's plus or minus, then you can just do that in one line.
Yeah, you could. I'm not sure what you'd necessarily gain. I mean, you could kind of squash it with the ternary operator, but that's not what I'm worried about though. What I'm more interested in is this is a bit ugly that we're calling plus equals in the constructor just because with 0 as well, just for the pure sake of fixing any weird value that we got. So what's a nice just some cut and pasting is all we really need here. But the question is, how much should we cut and paste? What should we cut and paste?
You could have an add method that takes pounds and pence instead of the object. And
We
then use
could,
that here.
but it's still doing a bit much, right? It's not. I don't want to call an add from the constructor. It's not idiomatic, is it? Really, it's not a. We don't want the constructor to be adding. The point is, it's just normalizing the value, right? If you get a weird value in pence, it's just doing this purely so it can normalize it. So, and there's kind of a hint in what I just said there.
So basically you want to convert this to pence.
We want to. So basically, the answer is we want a function that will normalize it, right? So I can just make a function called void normalize value, oh, sorry. And we can literally just take this, cut it out, call that instead, paste that in there, have this call normalize value as well, and I think that's perfectly readable now. You're right, I can. That's what I wanted to do as well, sorry. Oh, why did I delete it? Because I don't need it now. Actually, no, I will keep it. I will keep it after all. Do you know why I'm going to keep it? I mean, well, to be honest, the compiler's probably smart enough. But if it's runtime, it might not know. So depending on, if you have the values at compile time, it would probably be smart enough to optimize this call out. But no, I am going to keep it because if you are default constructing, there's no point doing the work to call this stuff because if it's 0, it's nothing to do. So yes, I will keep it because it avoids some wastage. What is this whining about? Oh, we should make it. Oh yeah, of course it's got the default. Yeah, I will keep the default constructor after all. I think it makes more sense. So we'll leave that alone, in fact. But does it make sense to everyone? This is just design. Oh, Tristan's got a question.
No, I agree with this. Avoiding calling normalized value.
So my question was going to be: do you want design question more than anything else? Do you want a constructor that just, or alternatively, equivalently, a defaulted argument for pence in that constructor? So you can just say money brackets 1.
Are you suggesting we have a constructor that takes only pence and then normalizes it?
No, the other. Well, takes only pounds.
Oh, it takes only pounds.
Because that's effectively what you had when you just defaulted those 2 arguments. You had a constructor that could be called with 1 argument.
Yes, so I agree. So basically that, right? We could mark, and we could mark it explicit now, but
yeah.
I
also know that if you only have pounds, you don't have to do normalization. So
I'm going to favour verbosity or expressiveness. I think usually when you're writing currencies, you expect to put both of them. So consequently,
that was why it's a design question.
Yeah, precisely. That's right. I think that makes sense. If you want to get really fancy, we could do a what's it called, a user-defined string literal operator that lets you convert a string representation of pounds and pence into the class. But I think this is good enough. So, right, let's see. We've got that whining at us, but that's just wrong. It's we're correct, not it. So I think is there really anything else worth doing with it? I mean, we've got the pounds, we've got the pence. We call normalized value. This obviously then takes care of all of that. Although this is slightly magical in that it's operating on the class instance, but it's private. It's our own detail. It's reasonably safe to let that be as is. So I'm judging by the silence in the room. I think we've done this class to death, and we're happy with it. Sorry?
You'd never just step back into the constructor.
Never what? What's wrong?
No, because so I mean reusing it.
Uh-huh. Yeah. So, since we have done it to death, it is now correct. We can go back to our rentable class, right? So at the moment we have a test that says, if we give it an iRentable, and now we're getting back to mocking, which hopefully should be a bit more fun. So we create our mock rentable object, we create a mock customer object. Do you guys remember why this one's a unique pointer and this one is not? Come on, one of you at the back. Well, not you, Parvez, you've already been talking. You reckon, it's okay, just have a go. Just even if it's a completely random guess, don't worry about it. Just you got to get your mind going, start thinking.
Needs to be unique, so it's not like you can have million of the same thing, same unit.
Didn't realise you were sitting at the back. I don't want to pick on any of you, but who thinks they can have a go? Come on. Be brave.
person who says correctly doesn't have to buy beer afterwards. Incorrectly, we have to 5.
That's not true. Don't listen to him. No? So the question is, why is mock rentable a unique pointer, but mock customer is just the value type? If you can tell me which line that might be relevant to this question, that might be a start for you.
Because customer, we don't care about customer in this case. We care about the stuff we are renting.
Well, we do care in a way, because we
Yeah,
still
but
it's
just a value, yes. So it doesn't
Yeah.
matter. But we're testing the stuff which we're renting, and we want to make sure that the stuff which we rent is unique.
no.
Is it just that, issue rental expects a unique pointer?
Precisely, it's because issue rental takes a unique pointer ultimately, and it takes ownership. It was going to own the object, right? So it takes a unique pointer, and it doesn't own the customer though. So you just give it takes a reference to that. So okay, hey, let's try something a little bit simpler then. So who hasn't answered any questions yet can tell me what that line is doing. It's on 2 lines, but it's basically 1 line. I've just broken it up.
So it said that you have to. So it actually requires a call of assign rental function, and the first argument of assign rental function will have to be ptr val. This
Equal to this.
yes,
Yep. Exactly.
which is, as I understand, mock rental.get. It's
It's the point of value of the
Yeah.
rental we create. Yes, exactly.
And the underscore is from Trumploy.
Exactly, that's trompe-l'oeil. Precisely. And obviously we know this test passes, we did it last week. And so we verify that assign rental is called. So if you look in here, obviously when we wrote the code, there it is. There is the call to assign rental in the implementation. This is the implementation, right? The testing starts after here. So you can see that it is making the call, so the mock will be happy and the test won't fail. Okay. So the rental controller is obviously fairly simple, right? At the moment, it can issue a rental. What else do we want this controller to be able to do? Actually, does anyone need a refresher before we? Yeah, let's have a quick refresher on what this was doing. So don't forget what we built, right? In the README, we said that we have a basic framework. So we need to create a system that can manage an inventory of rentable items, take care of allowing them to be rented. So we've basically done that part, right? We can issue the rental. Track an associated charge. So, we need to figure out what the price is for the permitted duration of the rental, and add any penalty applicable to the rental. Right, fine. So with that in mind, we can basically issue the rental out, right? And we mark the start time, right, which is now. The end time is obviously given to us. So what's a logical next step? Sorry? When do we really need to care about? So, well, when do we really need to care about it? When do we actually need to care in this case? We're not going to get too advanced, right? When's the most obvious point in time when the price of anything actually matters? Sorry? Not strictly speaking. So imagine the customer. So the customer's not paying up front, right? And also we don't know how much to charge. We don't know how much to charge them necessarily, right? Because they might be late. So basically, for the purposes of this, so where I'm going to propose we go actually, because I'm sort of opening this to you guys, is we really care when they return it, because that's when we've got them in the shop and we can make them pay. Right? So at the point in them returning it, we can check everything out. If we want to make a notification system that's saying like, "You're late, come please bring it back," yeah, that's a good idea, but we ultimately can't collect any money from them. So for the minimum viable product, as is commonly said, let's have something that can at least correctly bill them.
I guess it depends, because would you want to not check? Would you not want to check their balance before you let them out the shop with the video?
So I'm going to assume that for the purposes of this, it's a credit-based system, right? They've got a membership, and you know where they live.
What if the
You can send the lawyers off.
goods are lost?
Sorry?
What if the goods are lost?
That's a good question. That's a very good question. We currently don't account for the loss of the item, and in fact, we don't. Arguably, we should add a new function here, really, that says item, rentable value. So if they lose it, the value is the price they have to pay. But we don't currently have that in the interface. But it's a nice idea.
But how rentable? Okay, so the question is, should you add the value of, let's say, person kept the film for 5 days. So should you charge them for the 5 days plus the value of the goods, or just the value of the goods?
Oh no, it'd obviously be the 5 days and the value of the goods. Right? You still owe the.
Yes,
lose it.
you lose it, and after 5 days you come back to the shop and say,
sorry, I
really
lost
sorry,
it."
I lost it. So you owe because you accumulated for 5 days, so let's say
And
it's
you owe them
£5,
the value.
but the film costs, let's say, £10. So should you pay 15
Yeah.
or 10?
Yeah,
or
the
5?
rental period plus the loss. Because you still rented it. It's not their fault. It's not the. Okay, this is now sort of delving down the road of basically a legal argument, and we're talking about tort law, which is not really where I wanted to take C++ London Uni. But yeah, if you want to discuss tort, we can do it in the pub.
What if you send to the to the solicitors?
Oh dear. Okay, so we're gonna say that it correctly takes back a rental. Yeah, I think that's fine. So let's do our little comment, sort of BDD. Actually, no, let's have a go at BDD with this one. So I'm going to introduce you to scenarios. So scenario, and this is actually a slightly sort of slower way of of writing your test, but it does look a bit nicer. So we have scenario: a rental is correctly returned. Say correctly rental return is correctly handled. And build. Okay, so.
So just would you mind just going back a bit? What's the specific difference between TDD and BDD?
Oh, I'm sorry. Yes, you're absolutely right. Okay, I don't like to take a very strict view of what is TDD, because ultimately, I think at this point everyone pretty much agrees that when they say they do TDD, unless they're being pedantic, they're using the general term of writing some kind of test before they write some code. If you're being super duper pedantic, then this is sort of the strict case of TDD, as in it's just a test case, and it does some stuff, checks the stuff, and that's it, all gone and done. BDD, behavior-driven development, it's still doing that. You're still writing a test case, but the way in which you mentally think of that test case is quite different. So it operates in a given, when, then style. So I've basically done it here, but using comments rather than the sort of. And there's a separate benefit to BDD, which I'll get to in a second. But the basic principle is, given some initial stuff, when we do something with that stuff. And this is also where mocking gets a bit funky, because obviously the when is technically when I call the damn thing, then we should have satisfied the mocks, but it doesn't really work very well in this particular example, because I have to set the mocks up first before I can actually call it. But the general pattern is, given state, when I change something, do something with that thing, then this should be equal to this, and that should be greater than that or less than that, right? The then part is checking, right? So it's set up for given, modify for when, verify for then. And so the benefit you can get with it, sadly, It's not a thing in Catch at the moment, at least. But there's a BDD framework called Cucumber, which is Ruby based, and Cucumber actually does support integrating into other programming languages. You can use it with Java, for example, and you can even use it with C++ if you wish, but it requires some plumbing. What makes it nice is you can write these given statements, so given some whatever, and you can match on a regex. So each of those given, when, and then statements, which you write in plain English, I mean mostly plain English, obviously you want to fit a format, but I could say, you know, given, come on, we have the value 5, right? However, with Cucumber and this sort of traditional BDD style, this 5, right, is in what's called a scenario file, and your test code doesn't actually see 5. You do a regex match on this string, so you find this character and convert it from a string to a number, obviously, right? And then it means that somebody can come along, and they don't have to look at any of the actual code, right? Because these given, when, then pieces, in the case of Cucumber, obviously not here, but in the case of Cucumber, live separately in this scenario file. And so someone can come along, if they think of a new idea, they can just do, given we have the value 209, when we blah, 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 then blah, blah, blah. And obviously it can, the test code itself will extract via regex known pieces. So when you're writing new ones in the plain English, you still have to follow the general format. Otherwise the tests will just not work because they won't be able to process it. But assuming you do that, it enables your QA effectively to take some tests that are already written, the code's already written, but they can just think of how, have new ideas, and they don't need to know C++, and they don't need to know Java or Ruby or whatever it is. They can just write this semi-plain human language, English language stuff, and see what happens. Make sense? That's an extension to BDD. The basic way, though, is it's great. It's still good. I still think BDD is good for you as a programmer when you're doing this stuff in C++, purely because it allows you to organize and frame the stages of the test, right? Which we're gonna do now. So, given an instance of our rental controller, right? And obviously, I need one now. Come on. What do I call that one? RC. When we, so what are we going to need? We have issue rental. I suppose we call it return rental, right? Execute the return of a rental. So, actually, well, we're going to need some mocks, aren't we, as well? Let's we'll double back a little bit. So when we execute return rental, so rc.return eventually it will catch up with my typing. So I think we're going to need to give it roughly the same data as this, right? It's going to need a customer, which we haven't defined yet, obviously. A rentable. Actually, no, we're not going to, are we? Because the customer already owns the rental. If we're telling it to take back from a customer, we need to tell it the index of the rental to take back from the customer, right? Because the customer class already has it. So if we look at customer here, we can see there's a remove rental, right? So actually, it's going to be based on the index. So in fact, right, we're going to be customer first rental, we'll say. So that will just be rental number 0. And what else does it need to know? It doesn't need to know the time it's ended because we know what the time is now. That was already set in stone when the rental started. So that's basically all we need to give it, isn't it? Right? So, sorry? No, because the expiry is already saved on the object at the point of issuing it. So when we issue the rental, the start time is now, and the end time was already specified. Yeah. And I think would it make sense, I would say, that the rental controller can return the amount of money they owe. It's a simple. We can always modify it later. So amount owed equals that. Then the amount owed should be pounds, I don't know, 245. We'll make the mock settle that up. So check amount owed equals yeah. Oh, there was something else I forgot, which I'm going to do very, very quickly, which is take this struct, which we did, and I'm going to paste it back in there for 1 sec. Oh, come on. It does not want to scroll for me. Alright, we'll just use the keyboard. That's not working either. Option. Oh, that's taking ages. No, come on, that's way too slow. It's ridiculous. What is wrong with Sea Lion? Let's try it from the top down. Ah, there we go. No. Oh, yeah. Yeah, we're getting there. Cool. That just hosed the whole struct, didn't it? I said this is going to be quick. You know what? I really give up with this. Whew. Okay. Money. Paste. Thank you very much. Okay, right. All good. So back to this. So the amount owed should be equal to that, and obviously now we need to set up some mocks. So given it's a rental controller, and given a mock customer rental for 1 day costing, it's well costing, what was it, 245, right? So, you know, actually I will say that it does very much help to write this way, because I should have realized actually when I was doing this I could have actually put these as part of the given. So just shows following BDD does actually give you a quite nice structure. So obviously now we need a mock customer. So also we can have a mock rental, obviously. Let's just capitalize that. Okay, so we'll have mock. Come on. Mock first. One slight problem is obviously we've made this fall out of scope, so I need to actually nest that. So we need a mock. Oh, but are we going to take a unique pointer? Do we return a unique pointer to it? We do, so that's not what we need to do this properly. So auto make unique. Come on. It's so laggy sometimes. What absolutely blows my mind is that it's this laggy when, I mean, there's not really even any code in here. It's just a standard library. And right, what we got here?
I mean, you would be tempted to put all of that given rather than like and givens, would you?
Sorry?
You would be tempted to just put all that in under the given rather than nesting and givens.
Yeah, it depends really on how much you've got to do.
You intend to do 3 or 4 and givens.
No, I'd be more inclined to just briefly summarise the multiple things I'm doing in the and given, rather than doing like, I don't want to like I've already done that here, right? I could have said and given a mock customer and given a mock rental, but it's just excessive, right?
Or just no and givens.
Given a rental controller and blah blah blah. Yeah, you could do you could do that as well. In this particular case, just to separate them, it's okay. It's not too, but it is taste as well a bit, right? The point is that you're still following this format and it flows nicely. So we have a mock rental, and so the first thing we can expect, right, is it require call? Yeah, so require call, mock cast, and was it remove rental? What was it? Yeah, it was remove rental. So remove rental. With 1 equals 0. Everyone clear on what that's doing? I need to do return now. Dot return. Why is that not working? Okay, let's figure it out. Dot. Yeah, if the code completion worked, it would be truly tremendous because it will save me having to go to read the documentation, which, since it's 2019, I'd quite like to be able to do. Look at this. Awful. Okay. I'm pretty sure it's return. Must be return. Oh, great. Let's just sit around waiting for C-line for a minute here. Or just render itself unusable, why not? Please just let me type. Yep. Thanks. Stood move. There might be some plumbing needed. I suspect that returning by move. Yeah, I am desperately trying to cancel this, but it just doesn't want to. Holy heck. Okay. Let's see. Call implicit leak. Yeah. Yeah, that's no good, is it? Right. I don't have a fresh browser window that I've... Where's my phone? Can I have my phone, please? Thank you. So, if anyone can try and do this themselves first, who can quickly find me how to return by move in trompe-l'oeil? On your marks, get set, go. Oh, go for it. I've got to use my phone, so you'll have an advantage on me. Sorry?
Let's do a challenge. Typing and voice. That's Google Assistant.
Typing of oh, Lord, no.
Trampoline, active guide for awesome Java development.
Wait, what? Trampoline? Oh, Lord.
Trampolining.
Let's see, reference, matcher, macros, make mock named, return expression. According to this, it's actually fine, but it's not going to compile, is it? So, you know what? Let's just try and compile it and see what error we get. Call to implicit confirm. Oh, yes, that is no good. That is no good at all. See also LR return. Oh, okay. What about that? That's not going to do it, is it? Maybe that is going to do it. Yeah, okay, done it. So apparently, the solution is LR return. At least it's not erroring on that anymore. So this is obviously broken. So let's just get it to compile. We're not going to have any useful code yet, but we'll say money return rental customer ref, and then of course, you know what, I don't need 2 lines. Okay, so we now have a function. We can return nothing. Return rental is not implemented. I think it is implemented. It's literally there. What's wrong here? That's what's wrong. Okay, does that compile? Does it? It's promising. It does. So, great. Well, we've got our first failure, but I'm not finished with the test yet. So we expect it to call remove rental, right? The code's going to need to do that. It's going to need to calculate the money though as well, isn't it? So once we've given the implementation back the mock rental, it's probably going to have to ask the mock rental for some information, right? So if we look at the rental, it doesn't care about its title or its type. Probably cares about the rental start, doesn't it though? So it would care when the rental started, it should care when the rental's ended. We're not addressing penalty yet. That's not part of our test, so we won't bother with that just yet. But we will. We need to fill in the start and end, right? So in our test, we can have require. Oh, come on. And again with the lag, we'll have the mock rental. And so the start time can be, what, now minus 24 hours, I suppose. Yeah, I suppose. Just for accuracy, we can use chrono. So auto. Do I have it in there? Yes, I do. Right. And just for completeness, auto end equals start plus 24 hours. We've got chronoliterals. Yeah, we do. Everyone understand why the H there works? Looks a bit magical, doesn't it, in C++? It's part of a language feature called user-defined literals. So these aren't user-defined, they're part of the standard library. So you can add this line here that says you're using namespace stood chronoliterals, and then it gives you this set of suffixes that you can put on numbers to turn them into a chrono object. So it's the same as writing stood chrono hours constructor 24. So this is exactly the same as hours. Exactly the same, but obviously that's a lot longer, whereas that is a heck of a lot shorter. Quite nice. But in the end, you get the same object. You get an hours class. So that's going to return start, and of course require call not rental end. So when our implementation asks for the start and the end, we will give it back those numbers. And why is it? No, that's just fine. So subsequent to that, absolutely right. So subsequent to that, the rest should be internal, right? We've given it the start time, we've given it the end time. Oh wait, no, there's something that's missing. What is it missing? Well, we need the cost per day, don't we? So I won't expect the penalty per day because we'll essentially be within the expiry time, yeah? So let me... Actually, wait, is it cost per day? Yes, we need cost per day. And we'll say that for the purposes of this rule set, that if you return it after, say, 25 hours, then we won't bill you for the extra day. So we'll always round down, right? So in fact, we'll make that 25 for the leeway. So require call cost per day. Come on. And what was it? Was it money? A money instance it returned? Oh no, it's done it again. It returns money. Yeah. So if I go to the correct one, we said it should be 245, right? So that should basically give it all the information it needs, right? It knows the start time, it knows the end time, it knows the cost per day. That should basically have done it, right? In terms of what we need. So we'll find out because now we've got to implement the code. So as usual, the scenario, of course, should fail. I'm pretty sure it will with what I've added. And sure enough, let's see. What is it testing? This is interesting. What's going on here? Unfulfilled expectations. That's all the mocks. Yeah, good. So everything is not working as we want. So now for implementation. So the first thing we need to do is get the rental back. All right. So rental equals. That's actually a slight problem because if we let it do this, it's going to destroy the rental object, isn't it? This is a design issue now. So we return the money, but we don't return the rental. Any suggestions on what we could make the return type be so that we can get back both things? You said tuple? You said tuple? You said tuple. Yes, it could be a tuple. It could be something a little more specific than a tuple in this case, but yes, tuple is valid. Per, precisely. Any other ideas? And there's basically one more, right? That's sorry? No, not a vector. It's one more. Precisely. Could just be a struct of two members. So we can encode the type data. Alright, who wants to go with a struct? Should we go with a struct? Yeah, we vote for struct, alright. Sorry, huh? What? A Boolean? Oh lord. You got two states. It's one value with two possible states. So you'll have our struct. I'm just going to leave it here for now. Return info. And of course we've got the money amount owed, and we've got the stood unique pointer. So the rental is obviously going to be customer dot remove rental index. So we grab the rental, right? Then we need to start doing our computations. So we'll do auto, was it rental? No. Time equals rental. Actually, we want the end minus the start, don't we? So Actually, that's the duration. So I'm not testing for a penalty yet. If I'm not testing for a penalty, we just want the time borrowed, right? So we can just say system. Come on. So now minus the start, right? That's the total time they've basically borrowed it for. So actually we don't need the rental end at all, do we? Because we're not working out penalties. We only need to know the end if we're figuring out a penalty. So actually, the end is not necessary, right? So, oh, come on. So we have now, we have run out of time. Yeah, we've run out of time, crikey. Well, so we were just getting into that. It's been a fairly intense bit of TDD. I hope it's been sort of reasonably interactive. Yeah, one of the, before I just finish off, one of the best ways to program is actually mob programming, where you essentially sit, one person's at the keyboard, they're not thinking, obviously I have been thinking, and the people who are not at the keyboard are the ones responsible for helping to develop the code. So I think we've had that from this room, I'd say, today. So if you're not confident, don't worry about it. It's all about practice makes perfect, but obviously if you participate, it does help. Anyway, so on that note, I actually need to fix YouTube first. Sorry, folks. We're just going to transition over. So, as usual, thank you very much, everyone.
Thank you.
And as usual, we're going to the pub. And for those of you on YouTube, sorry you can't join us. Bye-bye.